Hi students, in the last class we have seen two forms of Green's theorem. So recall what are they? The first one says integral over a closed curve C f dot t ds. That means the tangential component of f, its integral. It's called circulation. And that circulation is related with the curl of f. So circulation and curl, they are related by way of Green's theorem. So that circulation is equal to double integral over r curl of dx dy. What is curl of? Recall by definition, curl of is nothing but dou n by dou x minus dou m by dou y. And the second form of Green's theorem says integral f dot n ds. So normal component of f, its integral, it's called flux. Flux is equal to, flux is related with divergence. So flux and divergence. Flux equal to double integral divergence of dx dy. Recall what is divergence? Divergence is dou m by dou x plus dou n by dou y. So circulation and curl are related. Similarly, flux and divergence are related. This is what is Green's theorem. We will see an example how to evaluate certain line integrals easily using Green's theorem. So, example, evaluate the integral over c xy dy minus y square dx for what is c? C is the square cut from the first quadrant by the lines x equal to 1 and y equal to 1. So x equal to 1 is this line, y equal to 1 is this line. C is the square cut from the first quadrant by the lines x equal to y and x equal to 1 and y is equal to 1. So this is your C in the counterclockwise way. C is as in figure. So we shall do this by the usual method. If I want to do this integral, what I have to do is call this part as C1. Which part? This is my C1, this is my C2, this is my C3 and this is my C4, and integral over C is integral over C1 plus integral over C2 plus integral over C3 plus integral over C4. That is, it takes too much of work. So what we do is, we use Green's theorem. That is the idea. So integral over C xy dy minus y square dx. Okay, if you call this as m and this as n, so this is integral over C m dy minus n dx. But what is m dy minus n dx? Integral? Yes, it is precisely your flux. Flux is m dy minus n dx. Flux is your m dy minus n dx. And what is circulation? Let us recall that also. Circulation is integral over C m dx plus n dy. So let us use the second form of Green's theorem. So what you will get? Integral m dy minus n dx is equal to double integral over r dou m by dou x plus dou n by dou y dx dy. So this is equal to double integral over r dou m by dou x plus dou n by dou y dx dy. This is equal to, so what is your m? M is xy. And what is n? It is y square. So what is dou m by dou x? Dou m by dou x is y plus dou n by dou y. What is dou n by dou y? It is 2y. 2y dx dy. So what is this r? This r is the region that lies inside C. So this portion is your r. This portion is your r. So here x varies from 0 to 1 and y also varies from 0 to 1. So here x varies from 0 to 1, y varies from 0 to 1. So you will get y plus 2y is 3y, and you are integrating first with respect to x. So y is taken as constant. So 3y into x between the limits 0 to 1. Then you integrate y from 0 to 1 dy, and x evaluated between 0 to 1 is 1 minus 0. So this is going to be 1. So 3 by dy. So 3 into y square by 2 between the limits 0 to 1. So this is precisely 3 by 2. So in just one step you are going to get the answer. That is the advantage of using Green's theorem. So here is the step where you have used Green's theorem. Okay. So this is method 1. Let us proceed in another way. So method 2, again by using Green's theorem, the first version. So integral, what is that? Xy dy minus y square dx, right? So write this as integral m dx plus n dy. So what is m? It is minus y square and what is n? N is xy. So by Green's theorem, m dx plus n dy, this is precisely the tangential component of f, its integral. So this is actually the circulation and curl are related. So double integral over r curl. So what is curl? It is dou n by dou x minus dou m by dou y dx dy. So this is equal to double integral dou n by dou x. It is y minus dou m by dou y. It is minus 2y. Dx dy. Here x varies from 0 to 1, y varies from 0 to 1. So this is equal to, this is the earlier step, this is 3y, and the rest of the calculation is the same, and you will get the answer 3 by 2. So for the exam you don't have to do both the methods, you have to just do any of these methods. Thank you.